So there are many ways you can configure NGINX, but if you've ever manually edited config and dropped the semicolons and messed around, you've quickly realized this isn't ideal. And NGINX.com has a commercial offering, which wasn't around when we first wrote this. And I'm just going to quickly detail how we solve this problem with two NGINX modules. So the goal is to dynamically provision sites based on control from other components within our software stack, talking to NGINX. No rewriting configuration files, just talking to NGINX. We are an enterprise cloud vendor. We co-sponsored WebSockets, I think it was. Yep. And what we are doing in our setup is running 2 or more NGINXs at the front end of the cluster, responsible for everything within a given domain, and having our customers spin up instances which have various subdomains of that, and have them dynamically come into play and be routed appropriately. The work I'm talking about, I'm the current maintainer of it. It was written by Kirill Kaskanovsky, who's no longer with us, unfortunately. And one of the 2 modules will be open sourced, but not the second one. So here's a typical cluster. You've got 3 different hosts presented to the outside world, one of which might have 3 backing instances. And if you're looking at the HTTP traffic, this is trivially easy. You understand what the data flows are. And all of this happens, the actual HTTP traffic is forwarded through existing modules. All we touch is the configuration of saying what should happen. We're not doing anything special to the actual traffic. So what we use to manage this is a substrate which is based on the PubSub Mode design pattern. With this pattern, what you're generally trying to do is make sure that the people who publish information don't need to know about who's consuming it. It means that you don't have to go around configuring individual connections and know of all your backends and all the rest of it. Everyone just knows about how to talk to the message bus, and then each component decides which topics to pay attention to, and they can communicate based on that way. We use something called NATS because our founder has been working with such systems for a very, very long time. He did stuff with TIBCO, who are well known in this space, and NATS reflects his current thoughts on how things should be designed. NATS has Ruby and Go. We use Go extensively inside Apcera. Most of our code is written in Go, except the stuff which is in C for NGINX integration. And what we actually have in our second module are the security layers which provide for JSON wrapping and unwrapping and encryption and verification to make sure that there's identity. So we actually add in component message level verification so that you don't have anyone who can talk to the message bus able to reconfigure NGINX. And this all happens very easily. The encryption is only currently used for the current active session key for talking to the authentication service. Everything else is open and just verified. So instead of the HTTP traffic, here's the controlled traffic, and you basically have a NATS bus. You just think of it as a common communications bus. And my colleagues will be screaming at the fact that I've just reduced all of our system down to controllers. Yes. But effectively, there are things which control the running customer application instances. There are things which control that, and they talk via NATS. And the controllers do not talk to the NGINX instances. They just talk to NATS. Here is the base level configuration. This is a legitimate configuration, except for the host names, for being able to reach NATS. That's all it takes in NGINX. And this is the module which we'll be open sourcing, but it only gives you the ability to talk as a substrate. So it's a clustering communication platform. They can fail over. We can kill some, and it should survive. This just gets you base ability to communicate. The next one for us, this is simple, but in large part it's simple because of that first line there, which is a path to JSON. We have a common policy configuration language, which is used by all of our components. And rather than rewrite things to NGINX, we distribute in the same format, including to NGINX. So we abstract the policy out. And then we just have a dummy server where the important line is the continuum router. And at this point, the policy file contains the public key of the authentication server, which can be used to verify the identity and setup. And this then is used for generating the ephemeral session key, which will be used for the NGINX talking with the auth server, and will be used to exchange credentials so it can validate the job servers as they publish route information. So what we have the two different modules, one just for handling the connections, one for managing publication of routes and the like. We've got JSON parsing in there. We've got signature verification, yada, yada. And the key point here is that there are two concepts, as you saw on one of the early slides. You've got the job, which corresponds to an externally visible host name, and then dynamic backends for each job, which appear and disappear and are dynamically added and removed from the NGINX configuration, so that as hosts go down or are restarted, or the customer scales up to 10 instances or 1,000 instances, or some are killed, NGINX dynamically adapts to this and knows where the backend is at any given time. The cool things in NGINX that I've seen are the way that you have the common framework for managing connections and connection state and communication across it, so that we could just plug into that, and the low-level NATS turns out to be surprisingly easy. And yeah, going on. And so to summarize, we have secure communications with message-level security. We're talking over a common bus so that we're not having to tie things together too closely. We have a good degree of decoupling, which provides for operational stability and flexibility. And we're able to do this in large part because of NGINX clean design and the ability to plug in extra modules which don't need to be involved in the actual HTTP routing. None of this affects the performance of traffic to the customer application because we are not in that data flow path. We are a control plane, not data plane. And that's it. We're Apcera, bringing speed and safety to enterprise IT, and we're hiring. Thank you.